Hi and welcome. This short video will explain the purpose of the Liftoff Assistant tool now available in Magnifi for desktop and Magnifi Go embedded already. In order to obtain the best results when performing eddy current inspections, it is often needed to perform an initial rotation of the signal in order to place a reference signal at a specific angle. This action can be required at the initial setup when adjusting frequency or starting working on a new material, for example, or even during an inspection work if the material properties changes on different sections of the asset. For example, on a pipeline, some permeability changes can occur along the way, and rotation of the signal can be needed to clean up the signal a little bit, if I can say. Most commonly, the plateau or the flat section of the liftoff signal will be rotated so that it is horizontal in the impedance plan. So it's rotating the liftoff to the horizontal is the most common reason why we would want to rotate the signal. But in some specific or more challenging application, a different reference signal can be used. For example, the background noise coming from permeability changes, for example. So if the liftoff is well controlled, but we only have noise coming from permeability changes, that could be the reference signal we want to rotate. But in all cases, the idea behind this manipulation is to, I'll say, improve the C-scan quality, or at least mainly keep the signal of interest visible on the C-scan by rotating on the horizontal axis the signal we need or want to eliminate or hide in order to only see the signal that interests us. On the screen right now, you can see at the top a C-scan showing a liftoff signal, so the large red portion on the left. And on the right of the same C-scan, you have a signal coming from a transversal notch. The top C-scan is what we can see before the signal rotation. Once the liftoff is horizontal, as we can see on the bottom portion of the image, the notch become easier to locate in the C-scan. So the liftoff is in the blue range of color, and the notch becomes more red, so easier to locate. In many applications where array probes are used, we also need to use encoders and some type of filters, for example, median filters. And those tools prevents us from getting rapidly the liftoff signal. So when we want to generate a liftoff signal to do the rotation, it means that the probe is lifted from the surface. Consequently, if we are doing an acquisition using an encoder, this means that the encoder will not be moving as it will not touch the surface. And so if the encoder is not working, no data will be gathered. As for the filters, the most common one is the median filter, and one of the property of this filter is that it's very good at filtering signal coming from liftoff variations. So as we can see on this image, at the top, no filters are applied, so we clearly see the liftoff signals. And the bottom C-scan shows the same data with a median filter applied. So if the filters are activated, it becomes difficult to do the signal rotation. Considering those two factors, the old way to perform rotation of the liftoff signal before the creation of the liftoff assistant implied that the users needed to access various menus in order to deactivate the encoders and filters and then to reactivate it afterwards. So multiple manual steps, which means risks to forget something along the way. So this is where the liftoff assistant will help save time and increase efficiency when setting the initial parameters for a new job or project. So simply to summarize why to use this tool and how it works. So basically, it's a software assistant to facilitate the liftoff signal rotation or any other reference signal we might want to use. It is meant to save time during probe calibration or initial setup by simplifying the signal rotation. When you're entering the mode, the software will automatically disable all encoders, all C-scan filters, um, the liftoff signal or the signal displayed in the impedance plan will show a group of channel simultaneously using the render cursor display that I'll show in a couple of minutes. It will also fit the signal to the center of the impedance plan to facilitate the rotation. And all encoders and filters will be automatically re-enabled when exiting the assistant mode. So now let's see how to use the tool and the type of results it will provide. The first step when you are in the front stage will be to access the calibration ribbon. From there, the liftoff assistant button is the first one on the left. Once you click on the button, a small window will open up showing the instructions to proceed to the signal rotation. This window is collapsible, so if you are working on a small screen or don't need the instructions, you can reduce the size of this window. You need to keep it open because if you click on the X at the top, it will exit the liftoff assistant mode. So you need to keep the small window open. You will also notice that the bars at the top and at the bottom of the impedance plan are now black. When you'll exit the mode, they will return to normal at the same time that the encoder and filters are reapplied. So we remember, as I just mentioned, that as soon as we entered the liftoff assistant mode, the encoders and filters were turned off. So starting from here, the first step is to annul the probe and then to start an acquisition. Once the acquisition is started, simply lift the probe from the surface, then press stop. Try to perform this acquisition at a speed that will ensure enough points are acquired during the scan. If you're going too fast, the shape of the liftoff signal will be jerky a little bit. And it might be more complicated to work with that type of signal. Once you click on stop, the software will automatically zoom in into best fit mode, and the cursors will automatically be adjusted to include approximately 50% of the scan axis and 50% on the index axis, so that the next step can be performed without any manipulation of the cursors by the operator. So you see that right now on the screen, the cursors, I clearly see the liftoff signal in the impedance plan. I don't need to take any action. Another important feature of this mode is the render cursor display in the impedance plan. So you can see in the impedance plan right now that there are multiple different lines. So this is the render cursor, which means I am currently seeing all the channels comprised between the two vertical limit of the cursor in the C-scan. So I have approximately 16 channels displayed all at once in the impedance plan. So when I see more channel all at once, it becomes easier to do a rotation that is good for the entire array probe. So now using the rotation button at the top of the impedance plan, I can rotate the signal to the desired position. You will see that while I'm rotating the signal, I'm seeing only one channel at a time. But as soon as I'll let go of the, the, the button, I will go back to the mode where I see many channels all at once. So as you can see here, I adjusted one specific channel horizontally, but the other ones are still lifted a little bit. So I might want to move down just a little bit more to have an average of all channels to the at the horizontal position. You need to do the rotation for all groups of channels, all C-scans that you have. So if you have multiple frequencies, you will want to do the rotation on all those C-scans individually. Once the signals are rotated and you're good with what you get, you can exit the liftoff assistant mode. This will reactivate the encoder and filter. Once you're back in normal mode, I can scan a component normally. So that's about it for the liftoff assistant mode. Uh, just to summarize, it's a tool that reduces the manual steps the operator has to achieve in order to set up the, the software prior to an inspection. I hope you enjoyed. I hope it helped you. If you have any questions, don't hesitate to contact us.